Hello from Leipzig. My name is Sebastian Vetter. I am a software developer at the Focus GmbH Leipzig. My colleague Mr. Siedler is engineer for geodesy and photogrammetry, and Mr. Kaminsky, as a stonemason, is one of the customers of our software MetigoMap, and he is working in the field of documentation and accounting for stone conservation projects. In the next few minutes, I will introduce you into our work of software development from the past 20 years, and I will start talking about documentation. At the market, there are several tools and methods to create object documentation, but often if you get an object documentation, it's quite a surprise in which quality the object was documented. But there are two important simple parameters to control the quality of object documentation that are resolution and accuracy. And here you can see a chart that is based on the experience of our work from the past 25 years. And for each new object, the customer has to decide which geometric accuracy and which image resolution he wants to use, depending on material and the object itself. For 2D object documentation, there can be digital image plans, CAD drawings, or also graphic paper drawings be used. And in MetigoMap, there are simple functions for creation of image rectification on the base of geometry, for example, by a rectangle or parallel lines. And if the object is more complex, then rectification should be done by reference coordinates, and they can be measured by total station on site, or currently it's also possible to measure them within the point cloud that comes, for example, by laser scanning. On the right-hand side, you can see a point cloud with measured reference coordinates. On the left-hand side, one image to be rectified. Here it is in more detail. And after the rectification of several images, they can be exported in a multi-layer TIFF file. This can be processed in Adobe Photoshop, and here you can see the final result of one image plan in scale of 1 to 25 and 400 dpi's. This is an example that should be done by the conservator by themselves. That means he takes an overview image rectified by parallel lines. In the second step, he rectifies detail images with the help of point matching. You can see one rectified image, 5 rectified images, and here the final result after processing in Photoshop. In MetigoMap, it's also possible to load textured surface model. After creation of user coordinate system, model views can be created that are to be used for creation of auto projections. And so you can see on the lower side, it's an easy way to create a 2D mapping base. This way can also be used for laser scanning data. That means at first scanning data need to be imported. Then user coordinate systems are to be created. And with the help of this data, model views are created that calculate auto projections. You can see at the bottom. In the next chapter, I will talk about the project structure from MetigoMap. At first, the mapping project. Mapping projects can be combined within one object hierarchy, and inside the mapping project, there are things like groups or classes to structure your mapping projects, maybe for different kinds of materials or damages and so on. For each group inside MetigoMap, you can assign different mapping bases like different images or CAD drawing, and you can combine several mapping classes. Here you can see the group management, which allows the variable combination of different classes. And here you can see a display of one group, of a second group, and a third group. And it's also possible to integrate legend with an automated quantity survey. You can see over here. For classes in MetigoMap, you can define the display setting, but you can also assign different attributes. And there are fixed attributes, maybe for quantification or history. And it's also possible to define user-defined attributes. Here you can see the class management. It's quite similar to the layer management in Autodesk. You can create classes or import classes. Each class has its special type, maybe for area or for line mapping. You can set the display and you can assign attributes. The mapping in MetigoMap is vector-based, which allows an easy editing of elements, and it allows an immediately calculation of quantity like area or volume or length and so on. Yeah, there are different drawing tools or intersection tools for areas available. Second part of project structure is the object hierarchy. Here you can combine several mapping projects from your one object into one object hierarchy, and all the projects are linked to one mapping template, which offers the possibility that all mapping projects have the same layer, class, and group structure. Here you can see a navigation map, which allows you to create a visual navigation through your mapping projects. Here you can see an example where the different colored areas on the navigation maps stands for different parts of the objects. And if you double click on one area, you will jump into the next navigation map. And if you double click here on a colored area, you will jump into the mapping project and start your mapping or evaluation. Here you can see an example how customers are working. So they are running with tablet over the scaffold, do their mapping, and after their work they can select one class, and the software shows in the navigation map how many elements are evaluated in which mapping project. You can see the class analysis, which shows you at first the content of all the mapping project within one hierarchy. And it also offers maybe correction if you have different classes with misspelling or something like this. And finally, it's possible to export all the quantities. At first, you need to select your projects, then you select your classes, and after setting some additional options, you will get an Excel sheet or maybe a sheet for OpenOffice. The third part will deal with 3D mapping on textured surface model. And if you talk about textured surface model that comes from structure for motion, for example, you must think about three quality parameters. At first, the geometric accuracy. Second is the point distance, which means the geometric resolution of the surface model. And the third part is the image resolution. For 3D mapping, we had an R&D project called ProQuato. And in this project, we worked on calibration for laser scanning. We developed tools for creation of multi-textured surface models. And we developed some tools for 3D mapping and evaluation. For 3D mapping, it's possible to import textured surface model, which allows the user to do 3D mapping directly on the 3D surface. And with the help of the model views, he will get an 2D printout, and each element in 3D has only to be drawn once, but it is shown on each model view where it's visible. Here you can see an automated creation of model views. At the top, it's an example for 6 model views from the room inside, and at the bottom, 4 model views for one figure from the outside. If you have large data or quite strong structured data, then you can work with segments to reduce data, or maybe to do easy evaluation on hidden surfaces. There are several tools for evaluation and for display for 3D mapping. And for development of 3D mapping, we always considered existing 2D tools. So the new 3D functions are quite similar to existing 2D functions. And here you can see model views from the 3D mapping. All the things you have seen up to here are already available in the current version of Mitigo Map. And the next thing I will talk about are new features that will come with the new version in the next year. And that is the 3D object documentation on the base of laser scanning. And in this field, you need to consider there are two quality parameters. At first, the geometric accuracy, and at second, the point distance of the merged point clouds. For laser scanning, an object is scanned from several positions, and the software offers a pre-selection at the import. That means here you can see all the scanned data from 21 scanning positions. Here you can see the pre-import, and all the red highlighted data will be removed while importing. And so you can see the result of several scanning positions reduced by the outliers. Here the data from one scan position is highlighted in red. And in the next step, all the scanning, the single scan positions need to be merged and thinned to one point cloud, and therefore the user defines one point spacing. And here you can see the example of 3 millimeter. And if you remember this example of 21 scan positions, you would have a total amount of 3,400 millions of points. After the pre-import, there are only 400 millions of points, and after merging with a point space of 3 millimeters, you will get a point cloud of 115 millions of points, or if you reduce to 6 millimeter, you have a point cloud with 40 millions of points, and these are point sizes or point cloud sizes which are possible to work with. In the next few slides, I will show you some examples how we have used merged point clouds in our daily work. At first, a point cloud where we have used auto projections as a base for 2D image rectification. You can see over here. And you can also see the auto projection of the point cloud is quite a good 2D base for evaluation. Here in the second example, we use the merged point cloud for analysis of deformation of the floor. And the next example is an example of creation of ground plans and sections. You can see the point cloud from the inside with colored sections. Here the sections by themselves, section of the ground plan. And the software offers easy functions or functions for easy creation of setting the sections position. And finally, the auto projection of the point cloud by itself. And now I will give an outlook into the future. Therefore, we have started an R&D project called Freeform for BIM with our project partners. We want to support shape-to-true 3D modeling for freeform shapes in this project, and we want to develop an IFC interface which allows import and export of BIM models and the BIM models including 3D mapping. And finally, if you think about all the companies like us that created already point clouds with the help of laser scanning, then we want to make these point clouds reused, and therefore we started development in the field of virtual reality. So it's possible to walk through point clouds and take some simple measurements, but we do want to do additional developments. And if you are interested to work with us in this field together, then feel free to contact us. Thank you very much.